Well, welcome once again to Take It Apart with Dr. Pete. Sorry, just getting things set up on the other monitor here. There we go. I finally have another monitor so that I can actually see what the chat says. Alright, so what we're going to be doing today is a DeWalt DW929 drill. And this is an 18 volt from back when it was mainly, I think, nickel metal hydride batteries, I believe, for this particular model. So here's what we've got. It looks as though there's a couple of diagrams, but let's switch over to the bench, shall we? Alright, so one moment, please. There we go. There's a towel on here today because of the fact that there's going to be grease. It's going to get ugly. And I'm also going to glove up for today's Take It Apart for the exact same reason. Alright. So, here we have the device in question. It's a keyless chuck on the front there, designed for use at 18 volts nominal. And looks as though we've got 2 gears and then a torque limiting clutch with a drill mode. So it'll click over all the way up to 17 and then it won't torque limit when you hit drill mode. Luckily, no security bits or anything like that. We just have a bunch of hex or Allen key fasteners here. Let's see, I think I've got the right one for that. Looks like we gotta get out the other kit of drivers. And also I need to get you folks a little bit more light and get the camera back a little bit further. And focused. There we go. Alright. So, these are hex. They're not Torx. So let's try 2.5 and see if that fits. Slightly too big. Is it a 2.0 millimeter? Slightly too small. Okay. So this is... Can we use a Torx to get at it instead? That's an 8 millimeter or a T8 Torx. Here comes a T9. T9 engages nicely. Okay, good. Oh, and of course, guess who forgot to change the name of his stream today? Alright. That's much better. Alright, so let's get down the magnetic parts dish here. And we'll keep taking these out. just wondering if I've got a T9 or something that'll fit for my little driver up here. If I do, that'll make this a lot easier. Oh, hello. There we go. Things just got faster. There we are. Looks like we'll have to use the extender to get the last two by hand here. Come on. There we go. Would be helpful if that didn't happen. Alright, there's one. Interesting. One size too small. Okay. Might have to do this the hacky way and just use a flat blade. That doesn't want to work either. Fun. Alright, time to see if I've got something in my drawer of random Allen keys that might possibly fit. That's way too small. That's too small. That's too big. Yeah, okay. So, got one left to get out of here. Let me double check that I don't have something in the other drawer of screwdrivers. Nope. Oh, that didn't do it. Yeah, there we go. No, that's one size too small. Dang it. I didn't think this had any security bits, but it doesn't have to if I don't have the right size driver for it. that's a 0.6. This is a T6. Oh wait, we need T9. What are you? That's a T9. Okay. Could be that this is just slightly stripped. Alrighty. Let's see if I do have a T10, because if it's stripped and I've got a T10, I might be able to still get it to budge. Who knew our undoing would be just one screw? Well, I guess I should have estimated that. That is the way of things, after all. Life is a lot of nopes sometimes for just one yes. And let's see here, that's square drive, that's pentalobe. Those are all hex in sizes that we can't use. Here's a security T10 that's a little bit longer from an old iFixit kit that I've got. See if I can get this out of its holder and try using it instead. Okay, it locks in, that's good. Cams. And the next size up is T15, so I don't think that's it. Alright, well, we may just have to get a little bit creative and or destructive with this. Probably the first thing that I'm going to try and do is lose a screw, apparently. Now, the first thing I'm going to try and do is get a drill bit in down here and see what I can figure out insofar as whether or not I can try and push from the other side. So we'll get like a 1/8 inch drill bit. And we will put that in from this side here. Oh. This side here. See if that engages at all. And we can try and get the screw to back off that way. Alright, let's put this back in, see if that was enough to stop it camming. I'm getting some amount of motion. But since I'm only after the motor anyway, I may very well break this. We'll find out. First and foremost, though, let's see whether or not the top is actually free. Get the trusty screwdriver here. And the top is indeed free. Good. Ha! There's a security tag in the bottom of this thing. Of course there is. Alright. It looks like we may actually be able to manage to unscrew this the brute force way by unscrewing the housing itself. There we go. Ah, who'd have thunk it? So that's the way this thing's going to come apart. I was not guessing that would happen. That would be the way that I got this thing apart. But sure enough, there we go. Yep. There it is. Here it comes. Ha! And there we have it, the last screw. Let's see if I can get it out of. Yep. Now it wants to come out. Come on, you. That's the way. There you go. Last screw out. Nice. Right, so while we were taking that apart, this fell out. And that's whoever had this last guy down the street from me who was tossing it while he was getting ready to move. I had what looks like a T25 in there. Just sitting in there waiting for action. So, fun that in the front you've got a little spring clip holder for whatever bit you want. Alright, so then the actual battery mount is built is rather corroded. And is built directly into the switching assembly, which looks to be both the directional switch up here, and also this feels like a continuous range potentiometer on here. So there's probably a MOSFET driver right in here. That's probably PWM'd or something of that nature, so pulse width modulated. Let's see if we can't figure out which side of this is positive and negative, and give this thing a little bit of power. Alright, so I just need to get my test leads out. Alright. So this thing's supposed to run at 18 volts. We'll see how many amps it decides that it likes to run at as well. But let's bring the power supply up to 18. And then, as I mentioned before, I'm not certain which side is which here. I'm guessing that's the wrong way to go. Oop, there we go. That was a nice little spark there. Something's up where when I turn that on, I'm drawing 5 amps at 1 volt. So I'm dropping to roughly 0 in the resistance department. This way, I'm only drawing about 22 milliamps. So something may be toast in here. What we're going to try doing next is we're going to try connecting directly to the motor itself. Motor, of course, is going to be a DC motor, so that means that, oh, yep. She runs. Alright, we're pulling about 25, somewhere between 25 and 30 watts on here. 5.7 volts, roughly, well, between 5 and 6 volts. at 5.1 amps. That's current limited by my power supply. That's going in that direction. Let's see what happens when we go the other way. Alright, we're getting around stable 5.3 volts, 5.1 amps. We go in the opposite direction. So, this is definitely an asymmetrical gearbox in here, built mainly for going forwards, not backwards. Why don't we remove these connectors from the trigger and switch assembly. Let's grab my pliers and do so. There we go. There's that. Alright, so let's put the rest of the drill out of frame for a moment here. You can see there is a hex screw right here. Let's see if that's the same size as everything else was. By gum, it is. Well, that's handy. Don't need all that many tools to get into this thing. So this seems like it's mainly just a heat sink right here, and sure enough, there is a FET right on the inside, a switch. It's interesting because the whole module is made to have just tabs right here. Then you've got these two clips for the nickel metal hydride battery. And so you'd feed current in through here. This is just going to be emitting heat into this metal radiator. And as it switches, and then your M1 and M2 outputs are just to the motor. On the side here, it actually says that this is a 25 amp 18 volt DC controller. RU rated, and a couple of other ratings on there. Also, we see on this side B plus and B minus. So let's try that one more time here. So B plus is going to be here. B minus over here. Right now we're drawing zilch. Alright, when I do this, we're drawing about 22 milliamps. I get this further up on the contact where it's a little bit less corroded. So yeah, 22 milliamps, and that's obviously with no load on the output side. So let's bring the drill back in. We'll just see if this thing decides that it wants to work now. I'm doubting it will, but let's find out. No, actually it's only drawing like 10 milliamps when I have the motor connected that way, and let's see what happens when we switch the terminals on the motor. I don't think there will be any difference, but let's find out. Oh, also, I should probably have the switch in a direction. And sure enough, there you go. By holding on to this, I'm actually tightening the chuck right now. Yep. Alright, so we're at 5.1 amps and 4.7, 4.8 volts. And if I flip this back in the other direction, sure enough, now we're loosening the chuck, and we're running at 4.9-ish volts. It's starting to get a little bit warm in my hand. Alright, good. So the controller itself actually still works just fine. And the that top switch there is just going to be tied to an H bridge, so it'll allow you to change whether M1 or M2 is respectively positive or negative on the output stage. Alright, so this whole thing, I don't think there's much that we can get apart inside of this, because this feels as though it's one of the potted units. Pardon me. There are tabs on the sides, but we'll save that. If we get around to this later, that's later, but we'll put that aside for the moment, because we really got to get into the mechanical guts of this thing. Right, so as with most common drills nowadays, cordless especially, it just sits right in the case. Another thing to notice here is all of this black, gross stuff that we've got on the inside. I'm guessing that since this is a brushed motor, we might be seeing the remnants of the graphite brushes on the inside there. And by the way, this is just the little arm that connects to that directional switch. And then up here, this piece is for switching back and forth between the two gears, between high and low gear in the gearbox. So that'll control your speed and torque, respectively. Well, both at the same time. The speed on this drill is going to be roughly inverse to the torque. Alright, so let's see if we can't get those brushes out and take a look at them, because that's where the wear and tear will be. And if that's... well, let's see what happens. There's a small little copper-coated coil spring here that seems to be holding that in place. It seems like there's a good bit more meat left on this brush, at least. Yeah. There's probably at least another centimeter left on there, so that's a good amount. Let's see if the other side looks about the same. The other side, if anything, looks a little bit less worn. Yeah, there's plenty of meat still on there as well. Alright. So those springs just hold everything in place there. Got a good bit of dust on the rear bearing here. So that's another interesting thing, is that the way that this sits inside of its housing. Alright, so let's see here. So the gear shift side is up. The way this sits inside of the housing, there's no actual mechanical coupling between the rear bearing and the housing. So this isn't actually a thrust bearing in the back here. This is just for axial holding entirely. That means that all of the loading that happens to this drill when you're pushing it forward falls on this little ring of plastic right here at the front, engaging with these little annular rings on the side of the drill enclosure, on the side of the clamshell or the case. So let's see what happens if we try and get the gearbox off of here. So it looks as though this is... oh, and here's the clutch piece. There's this little pin right here that engages with the back of this. So as this loosens, then we're going to get less and less torque needed to cause this to slip. In fact, you can see right there part of the clutch assembly. And as I've loosened that entirely, now we see we've got the little spur gear right on the front of the motor. And then back here, we can see the planetary gears that go over the top of that. So as I move the rest of this, you can see that this is a multiple stage axial reduction gearbox. So from here on down, all of the stages that lead into the very front of this are going to be reducing the speed from the motor. So the motor is going to be running a lot faster than the front of the chuck is. Alright, so insofar as getting inside of this nice metal gearbox, I think the first thing we've really got to do is get this spring clip off of here. So let's do that. There we go. And then it looks as though the halves of this are pinned in place, but let's first get the spring out of the way. There we go. So now that that's out, we have a pin in here and one back in over here. There we are. So this is the back portion of the planetary gear arrangement. So as these 5 gears turn around the main spur gear at the center, so these 5 right here are going to be linked linearly up to this, and then that means that this secondary pinion at the front there is going to be driving the rest of the assembly. So right now we've got what looks to be 1, 2, 3. So from the back to the front here, this is going to be roughly 1-to-1 right now. And then when you reposition this, do the shift in gears, then that's instead going to disengage the center, and it's going to be a 1/2 gear reduction. So that means that we'll get more speed out of that side. Then we have our next layer up here with 5 more gears. Once again, planetary gear box alignment to this. And then this exterior ring right here is what's going to be doing our... that's what's actually going to be forced by the clutch to let go. And the rest of that is attached at the very front here to the to the front portion of the chuck. So right now I'm looking down in there and seeing if there's a way to get this free rather easily. Honestly not seeing one. It seems as though... Oh, okay, so this chuck is... looks to be a friction fit. There's a little bit of a spline down in there. Let me see if I can get some more light over it for you to see that. Yeah, you see right in the middle there, there is a little spline that is coming up through, and that's the back of the chuck. Let me see about where the hammer for that. It's small, but it will do. We'll hit from the front first, and then we won't need to, because the whole gearbox just slips right out the back. Okay, that makes sense. There is a lot of oil on this thing. Right, and here you can see the little springs and fingers there actually doing the pushing against this part of the gearbox assembly to basically modulate the amount of torque that we have. So then in here we have the back of the chuck, and then is this loose or is this screwed in? Alright, this part's screwed in, but we can actually unscrew it. That's good news. For myself, I'm mainly after the motor in this thing because it's useful, especially if you're thinking about trying to make a generator out of it, which I am, eventually. But that being said, having this chuck, having the rest of this assembly, that's all good too, because the thing is that this is a spindle, and so there's a lot that you can do with that. Let's see if this is actually coming out, or is this just spinning around? Because I did say it's a spindle. Another thing that I'm noticing is that there's actually not all that much grease in here either. which kind of leads me to believe that there's probably... We're lucky to see as little wear on these metal gears as we're seeing. But that being said, I mean, these are all... Let's see, are they machined or are these sintered? These look as though they're actually machined metal gears. So, relatively expensive stuff. Good on you, DeWalt. Alright. Well, I think we're not going to be getting the chuck the rest of the way off of here, because this is not just screw or unscrew. This is set in place. And my guess is that that's the back end of a bearing right there. Anyhow, glad I wore gloves. And with that, I'll close up shop and say thanks for watching. See you next time.